Now, what do you mean by kinetic energy? Let me tell you what is kinetic energy. So, kinetic energy is the form of energy that an object or a particle has by a reason of its motion. Kinetic energy is the property of a moving object or particle. So, let us see different states of matter and their properties. So, the matter around us can be classified into three different states: solid, liquid, and gases. The following table provides a comparison of three states of matter. Let us see the table. Properties. Mass. In solids it's having definite, in liquids it's definite, and also in gases it's definite mass. Volume. Volume in solids is definite, liquids is definite, and gases is no definite volume. Let me tell you what do you mean by volume. So volume uh, is the quantity of three-dimensional space enclosed by a closed surface. So it's the amount of 3D space a substance or object occupies. So now let us see the shape property of solid, liquid, and gases. Solids are having definite shape. You can't mold solids by your hand easily. It first have to go through the liquid or gaseous states. Then only you can convert solid into any other shapes. But they are not having any. But they are not easily moldables. Therefore, they are having definite shape. Liquids are not having definite shape. They take the shape of the container. Suppose you have water in your glass and you poured that water in your bowl. You might have observed that when the water was in the glass, it took the shape of the glass. But when the water was in the bowl, it took the shape of the bowl. The water is of the same quantity but took the shape of the container when poured. Gases are also having no definite shape. Now let us see about the density. Solids are having high density. Now what do you mean by density? Let us see. So density is the mass of a unit volume of a material. Mass upon volume is the formula for density. So it's the mass of a unit volume. Unit volume 1 kg volume mass. Volume of unit of any of the solid, liquid or gases is density. So in solids it's having high density, of liquids is lesser density than solids, and in gases it's having the least density. Compressibility. We are going to see about it in the transformation of various states of matter, but let me tell you a little bit here. So suppose you are having one ice cube, water, uh, you poured it in one container, you pressed it. This is one activity in ninth standard. You might have had observed it before only, but let me tell you it one more time. So suppose you are having water, then suppose you are having water here. You pressed it by using a piston. Piston is like this. You pressed it using a piston. Then water gets converted to liquids. Okay, suppose this is gaseous state. It's vapor. Suppose you pressed it, it gets converted to water. Water are having less intermolecular spaces, as we know. So the molecules will get attracted to each other more. Therefore, it gets converted to water state, that is liquid state. And when you press it more, then it gets converted to solid state, that is ice. So pressing is the compressibility, that is how much you can press any state. So solids, we cannot press solids. See, if you're having one pen in your hand, try to press it, you can observe that it's not able to press. You can just fold it. If your pen is made up of cardboard, you can fold it, but you can't press it and make it thin, thin and thin. You can't do it. In liquids, they are slightly compressible. See, I have shown here that if you compress liquids, that is water, it would get converted into ice. It will get converted into ice. And gases are highly compressible. Gases can be converted into water also in the solids. Therefore, they are highly compressible. Rigidity. Rigid cannot flow. Rigidity means how much it can flow, how viscous it is. So you can't flow solids. See, try dropping your uh, get the caught of your pen at the height and try just swing it, swing it, swing it. You can't observe that the pen's nib is getting down, down, flowing, flowing. You can't see it. But when you pour the liquid from height, it starts flowing. So it can flow. It's fluid. In gases also, if you can't observe, but uh, you may perform one activity. You can spray one perfume in your room, and after some time you may observe, you may spray your perfume at one corner of your room, and after some time you may observe that the smell or the scent of the perfume is spread all over your room. Why this happens? Because gases can flow from one place to other, that is, they are fluid, but solids are rigid, can't flow. Free surfaces. Solids are having any number of free surfaces: hexagon, pentagon, octagon, nonagon, decagon, and etc. Liquids are having one free surface, that is only the upper surface. That is, if water is poured in one container. Okay, so this is one container, and here is up to here is water, then this is the surface. But gases are not having no free surfaces. You can't see gases, then why? Then how can you state that they are having any surface? No, it's not having any surface. So the thermal expansion, that is when you provide some heat to water, you can see that water gets converted to gases. When you provide some heat to solid, you can see that solid gets converted to liquids. That is only the thermal expansion. Thermal energy means heat energy. Thermal expansion, expansion due to temperature changes. So, what is thermal expansion? Thermal expansion is very low in solids, higher than solids in liquids, and much greater than both solids and liquids in gases. So the thermal expansion is most in the gaseous state. Now let us say diffusion. Diffusion in chemistry is the movement of matter, liquid, gases, solids, not solids, of fluid. Diffusion is the movement of fluid from the region of high concentration to the region of low concentration. No, this is the definition of diffusion according to biology. So what is the definition of diffusion according to chemistry? Intermixing of molecules on their own at certain temperature is called diffusion. Note it in your notebook. So solids do not intermix with each other molecules. Liquids, some liquids can diffuse spontaneously into other, example water and alcohol, but others do not, example oil and water. See, water and alcohol can intermix each other, but oil and water cannot. You can see oil's different layer formed on above the water surface. Gases diffuse spontaneously and rapidly. Therefore, we are advised to wear mask during COVID. So now